In COP 2000, you learned about a topic called arrays. And basically, what an array is you take a type and then you set it to an amount you want, and you have a contiguous block of memory. And so that that probably sounds a little weird. So let me go ahead and give you an example of that. So this is, let's say, this would be what we would do in COP 2000. We would say int my array 10. So now we have an array of 10, and then let's go ahead and and then so depending on what you're doing, you might directly assign things. You might say that, so that's valid. And then the first slice would be 5. And if you run out, you'd typically have to change this. Say it turns out we need 20 instead of 10, then you'd have to change it, recompile your program. And what you might do is you might get a little sneaky and use a define, pound define, and say size, and then you might do something like that. That way you can change these things later. And just a note, I don't want to sidestep too much, but see how I did all these in capitals? So when you're doing the pound define, typically this is the style. You do these guys in all capitals and your variables in all lowercase. Depending on the language, sometimes you do something called camel case, but I don't want to get into that too much, but that's just why I did all caps for size. That's the typical usage, and I'll probably do a whole video just on how you name things typically, naming conventions. But don't worry about that too much. So and if we needed to change the size, then you just have to change it up here. You still have to recompile, but you don't have to change it in a bunch of different places in your program. And so one of the things other ways you might use this is you might use it in a loop, something like and then my array, and then equals something. Let's say we wanted to zero out that array, then we do something like that. So this is a little bit of review. Don't worry about too much about the actual syntax, because we're actually going to learn something a lot cooler, because I've just mentioned the limitations is that basically if you run out, you have to change the size, increase the size, and recompile the program. Well, for a lot of programs, that's not really practical. And so what an advanced C or C++ programmer might do is they might use dynamic memory allocation. So I don't think you would have learned this in COP 2000, but in C there's something called malloc, and you do a memory allocation. And within C++, the equivalent is the new keyword, and basically you're dynamically asking for memory, and then you have to manually release that memory. So right now we're using something called automatic variables, but you can actually ask for memory from the computer. Actually, what you're actually doing is asking for it from the operating system. But that gets really complicated, especially for beginning programmers who might have just had a semester of C or C++. So let's just wipe all this and let's come up with a simpler way. So there's something called the standard template library, STL, and we're going to do an include of one data structure with an STL, and this is known as the vector, and this is actually basically a dynamic array. So when a lot of stuff happens in the background, but basically you ask for your some default amount, and it's changeable. But let's say the default is 10. You ask for an array of size 10, and then once it reaches 10, it grabs a new piece of memory and it copies over those old 10. And that new piece of memory is typically, I don't know, let's say 20. And so now you have your original 10 items plus another 10 to be able to use as you please, and then it goes back and it cleans up that old memory and it deletes it. So it takes care of all that for you. It's very nice to use. So here's the actual syntax how to use it. So you type in the data structure, and in this case we're going to do a vector, and then we're going to do a vector of integers, and so you can see these little symbols are and I'll zoom in really big for a second. We've got our left angle bracket and our right angle bracket. and then I'm not sure the size I was at before. That's probably big enough that everyone can see. Um, so we have our left angle bracket and right angle bracket, and then the data type. So that's kind of cool. Basically, we're using one vector library, but we can pass it different types, and this is a very cool feature of STL, and we'll get more into that later. But basically, it's a type of generic programming. So basically, they just wrote one vector library, and it can take integers, it can take strings, it can take floats, it can take pretty much any data type. So the next thing we do is we'll say my vector as a name, and then so to actually use this thing, so the object-oriented videos I've done so far were kind of short and they were just an overview, but there's actually a class called vector, and then so we have an instance of the class called myVector, and so let's do some things with it. We can add things to myVector, and so we say myVector dot, and then if we want to add something, it's called pushback, and then let's add the number 5, and what we can actually do after that is, well, there's two different ways, and I don't want to get too much into operator overloading, so what I'll do is let me see if I can remember the name of this. My vector dot, I think it's at, and so we'll say at 0. So yeah, that looks like it. This isn't the common typical usage. There's something called operator overloading. I'll show that in 1 second. But we'll just do the dot at. So we have our pushback method. So somebody made a class called vector, and then there's some extra stuff in here, but really what we're concerned about is the class called vector, and you can see how we included it, and we use the angle brackets because it's a part of a system library, and we're making an instance of that. And then so within that we have a method, a function called pushback, and then it takes one argument, and then so we're actually at this point, so at this point in time we don't have anything in our vector, and then at this point now we have one thing in our vector. So this is the whole state versus behavior, and so now we have a new state. Our state originally is nothing in our vector, now we have one thing in our vector. And then we also have a method called at, and we give it an index, and we're trying to find the first thing. So we can use that with a cout. Let's do a cout, and then we should just get 5. So let's, if anybody needs to copy that code, let's take these comments out. You get the drift of what's going on there. Okay. Start without debugging, and let's make this bigger as well. So you can see the number 5. So that's what's in our 0 index. So those are essentially the main two operations. You're adding things to vectors, and then you are getting things from vectors at a certain index. This usage isn't super common. I mean, some people use it, some people who are purists. In C++, there's something called operator overloading, and this is kind of a cool thing, and we won't get into it too much right now, but let's say this is really the more common usage because people are so used to using this kind of a bracket notation that you'd with an array. So you can just pretend this is an array and use it just like this. So this first line of code, this top line right here, is the equivalent of this line. The reason we can do this is because of something called overloading. And with a lot of different data structures, there's some sort of typical overloading, especially things like arrays and lists and all these other types of data structures where it just becomes a lot easier to not really care about the underlying implementation, and we just kind of sort of treat it like something that's like an array. So we'll get 5 in the first one and 5 in the second. So say we wanted to loop over this. So we would and I, and then we'd say for I is 0, I is less than, and there's a size property. So take a second and really think about what's going on here. Just on your own, look at this piece of code and say, what exactly is happening here? Okay, so what's going on here is we're saying our vector has some certain size. Right now the size is just going to be 1 because we've only added one thing to it. So we're saying I is equal to 0. We're saying while I is less than the vector size, which is currently 1, we do I++. And because we can kind of sort of treat this thing like an array, we could have just as easily, instead of this, done dot at I, and let's initially do that syntax. I'll say up front, people tend to not really use this at. I couldn't even really remember the name of it because it's not really used that often. But no, okay, what is it? What is it not like? I think size is a size. There we go. Sorry about that. I thought size is actually a method. Sometimes you can use a method. Sometimes you can use it as just a variable. In this case, it's a method. So really, reading the code in English is essentially the same thing. You're saying my vector.size, and then it goes in and it figures out the size of it. But as you can see, it's going to go through and say we have 5, and say we add a few things. Let's say 5, 7, 9, 11. And then it printed all those things because it's inside of a loop. So I hope you kind of see how cool this is, especially with STL and vectors. It makes life a lot easier. Some people don't care for STL, some older programmers maybe, because STL came about around, I want to say around 2000, and so people who had previously gotten used to the methods that they're used to will argue that STL is better. But I would say in general that new code you're going to see will probably make, especially C++ code, pretty good use of STL, so you won't have to deal with arrays and dynamic memory allocation. Well, you'll still have to do that, just not for your own data structures. So it's a very cool thing. I understand this might be a little bit of a complicated video. Let's just go over what's been written so far, top to bottom. So our normal includes. We have our vector include, because we're going to be using vectors, which is essentially a dynamic array. We have our vector class. So remember from the previous video, we're starting with object-oriented programming, and that's why I did sort of a gentle introduction to object-oriented programming. But this is actually a class, just like a cat or a dog or a database or whatever. This right here is a special STL notation, and you'll get used to this. But it's basically the data type within angle brackets, and then our specific instance of the vector. And then so we're calling methods within the vector. We're saying my vector dot, and then we're doing a pushback, which is essentially add to the end of the array, or I should say vector. And then we do it multiple times. And then so here now we're going to go ahead and loop through our vector. So we're going to say I is equal to 0, while I is less than the current vector size, and the vector size is actually going to be 4. So we get to go through this 4 times, and then we're going to do an I++. And then so now we have 4 things within our vector, our dynamic array, and then now we're going to print those to the screen as we go through. And just to show you the other syntax, I'll run this real quick, just so you. Oh, it's not dot. It's just like that. There we go. Same thing, equivalent. So don't worry about operator overloading too much, but that's the reason we can do this. And then I'll continue with some more of these cool STL data structures in the next video.